Hey there, everybody. In this video, we are going to be evaluating limits algebraically. We're going to see a handful of different tools to put in our toolbox to do this. We will be spending quite a few days in class just getting some extra practice reps and noticing patterns on these. But here is just a simple little video, hopefully simple, that will discuss some of the techniques. So, when we are trying to evaluate limits, your first step is always just plug in the number as x approaches whatever value. If you can plug it in, do it. It's only when our function is undefined that we have to tackle some strange behaviors. So if you plug it in, if you're lucky, you'll just get some number. Or maybe you might be, get 0 over a number, but 0 over anything is just 0. More times than not, we're going to get 0 over 0. And that should be a huge indicator that something might somehow cancel out or remove itself. So we're going to factor, we're going to talk about conjugate pairs. Conjugate pairs, just as a reminder, are things that look the same, but one has a plus, one has a minus. Or we might have to simplify complex fractions, fractions within fractions, fractionception. Ooh. Also, when we plug it in, you might get some constant over 0. So if there's a 0 in the denominator, well, then we have some real funky business, probably an asymptote of some sort. Could be other scenarios, but that's typically when we see our function does not exist, our limit does not exist, or we are approaching positive or negative infinity because there's an asymptote. So, let's take a look. First, we have limit as x approaches 2 of x squared plus x minus 6 over x plus 3. Well, if I just plug in 2, I'd get 2 squared plus 2 minus 6. Let's see, 2 squared is 4 plus 2 is 6 minus 6, I get 0 up top over 2 plus 3, that is 5. 0 over 5, that's just 0. Okay. So there's my limit. Nothing funky happened. The other option would be take a look at a graph. If we're approaching 2, as I go at 2 from the left and 2 from the right, it looks like those have the same exact destination. That destination, you guessed it, 0. So we can just plug it in. Nothing weird happened. Cool. But sometimes there will be weird stuff. So here are the different options. This is not necessarily a step-by-step. This is more of a menu for different techniques you can do. Always, one option is just plug it in. That's what we just did. Next is factoring. Typically speaking, factoring your functions is going to be a very good first step if it's not already factored. If you have radicals tend to be the biggest giveaway. You're probably going to want to multiply by conjugate, because when you multiply by a conjugate with radicals, the square root tends to vanish. Simplifying complex fractions is when you have a fraction within a fraction, so I'm just making up an example here. So we'll talk about how to simplify those. There are a number of ways to simplify these. And then the last one is always graphing as an option. You guys have machines that are in your hands that can graph things for you. Use those to your advantage. All right, first, limit as x approaches negative 3. Can I plug in negative 3? Let's see, that would be a 9 minus 3 minus 6. So 9 minus 3 is 6, minus 6 is 0 over 0. I get 0 over 0. Can't do that. Okay. So direct substitution is out. Let's try factoring it. I'll factor the top. Numbers that multiply to negative 6 add up to 1. I'm getting a negative 3 and a plus 2. Down below, nope, I had those backwards. Classic Mr. D. Plus 3 minus 2. There we go. Down below, we still have that x plus 3. Well, holy smokes, wouldn't you know it? X plus 3's cancel. So I'm just left with x minus 2. I can plug in the limit as x approaches negative 3 for x minus 2 now. Negative 3 minus 2, well, that's going to be negative 5. And if we cheat and look back at our graph, when we approach negative 3 for an x value, there's a hole in the graph, removable discontinuity at negative 5. Wowza. All right. Well, let's try something different. I don't know what this graph would look like. This is all sorts of bonkers. Let's see if I can plug it in. 0. Okay, I just get a 0 up top. Down below, 0 plus 1 is 1, square root of 1 is 1, minus 1 is 0, I get 0 over 0. So anytime you have 0 over 0, that's a big indicator that somehow, some way, some shape or form, things might cancel out. Now, as I alluded to before, anytime you see radicals, typically that's going to be a dead giveaway that you can want to multiply by conjugates. So what a conjugate is going to be two factors that look identical. Only one has a minus sign, one's got a plus. The two terms inside are going to be the exact same. So over here, I'm going to have the square root of x plus 1. And instead of minus 1, it's going to be a plus 1. Now, I can't just multiply that down to that denominator all willy-nilly like that, because now I've changed the value of this fraction. What I have to do is be balanced, and whatever I do to one side of the fraction, I have to do to the other. Because what I have here is technically just a value of 1. Anything over itself is just 1. So I'm multiplying by this fraction by 1. I'm not changing the overall value. All right, so now let's see what happens here. The top part, I am not going to distribute. So leave that top alone. X times square root of x plus 1 plus 1. Over. Something interesting is going to happen here. We're going to have square root of x plus 1 times the square root of x plus 1. Well, a square root of anything times a square root of anything, the square roots just cancel out. Right? If I had the square root of 5 times the square root of 5, that's just 5. So here, the square root of x plus 1 times the square root of x plus 1, that's just x plus 1. Then we have a plus 1 times the square root of x plus 1. And then we have a negative 1 times the square root of x plus 1. And then we have a negative 1 times 1. That's a negative 1. So the beauty of conjugate pairs is these two terms, these two pieces in the middle, will always knock each other out. So these two pieces will always knock each other out. That always happens with conjugate pairs. So now my denominator is x plus 1 minus 1. Well, hey, check this out. Plus 1 minus 1, those go away. So now my function looks like the limit as x approaches 0 of x times the quantity square root of x plus 1 all over just x is down there. Oh man, these x's will cancel out as well. So now I've got the limit as x approaches 0 of the square root of x plus 1. Now I could probably plug in 0 here. If I plug in 0 for x, I get 0 plus 1 inside of a radical. Plus 1, that evaluates to 2. Now, the more you do these, the faster you're going to get. It took us quite a while to get from here to here. The more you see of these, the more you'll fly through. All right. If we saw a graph of that, here's what it would look like. So it looks like there's a hole in the graph at 0, 2. All right, next one. Limit as x approaches 16. I cannot plug in 16. Because if I plugged in 16, I get a 0 on the bottom. If I plugged in 16 up here, I'd get square root of 16 is 4. 4 minus 4 is 0. Shucks. So we're going to have to do conjugate pairs. Now again, the way conjugate pairs will work is the middle terms cancel out. Now the issue some people run in is which part do I do conjugate pairs with? Here's my advice to you. Whichever side of that fraction has a radical or a smaller number, do conjugate pairs there. So I'm going to do a conjugate of this numerator, 4 plus rad x. Whatever I do to the top, I have to do to the bottom as well. I'm going to leave that bottom part factored. I'm not going to touch it. The top part, I will distribute. So I have the limit as x goes to 16. If I distribute, 4 times 4 is 16. So 4 times 4 is going to be 16. Then we have a 4 rad x and a negative 4 rad x. Those will cancel each other out. And then the last term is going to be negative rad x times rad x. That's just going to be a negative x. So I have up top a 16 at the start, a minus sign, and then whatever this term was squared, in this case, x. All over, again, I'm not going to distribute that denominator. 16 minus x and 4 plus x. Well, some of you might notice, check this out, 16 minus x, gone, goodbye. So I have the limit as x approaches 16 of 1 over 4 plus rad x. Well, now I can plug in 16 here. The square root of 16 is 4, so this would be 1/8. All right, onward we go. Now to complex fractions. Oh boy. Here we have a fraction within a fraction. That's no bueno. First, let's see if we can just plug in. If I plug in 0 for x, this would be 1/4 minus 1/4 over 0. That's 0 over 0, no can do. Crap. Okay. There's a number of ways to do this. Here's the way that I prefer to do it. You do you. First, we have to just kind of accept the fact. I'm going to take an aside here. If I saw something like 8 divided by 2, I could claim that that is the same as saying 8 times 1/2. I could split this into a multiplication problem. I'm going to do the same thing here. So I'm going to say that we have this numerator times 1 over that denominator of x. So I'm going to rewrite this as limit as x approaches 0 of 1, oopsies, didn't give myself enough room, 1 over x plus 4 minus 1 over 4 times 1 over x. So all I did is I rewrote this numerator and then denominator. But I changed it from a division to a multiplication. Now we're going to see why that works here in just a second. All right, inside the fractions here, this would be mighty fine if we had common denominators, because then I could actually subtract these. Unfortunately, we don't. Well, let's make them have common denominators. So to get common denominators, we're going to multiply this first fraction by 4, and then we're going to multiply this second fraction by an x plus 4. And holy smokes, wouldn't you know it, now those denominators have the same components of 4 times x plus 4. So as we simplify this, we have the limit as x approaches 0 of 4 minus 1 times x plus 4, so x plus 4 is in parentheses there, over 4 times x plus 4, times 1 over x. Some of you might already be looking ahead and seeing what happens here. This negative sign is going to affect everything in the parentheses there. So if I strip away that negative, or those parentheses, this plus becomes a minus. Once that happens, this 4 and this 4, they're going to knock each other out. 4 minus 4 is 0. So I have negative x over 4 times x plus 4 times 1 over x. I'm going to rewrite this just to clean things up a little bit. The more you do of these problems, the faster you'll get. You'll probably be skipping some of these steps. So here's currently where we're at. Well, now I'm seeing, hey, this x and this x can cancel. So now if I rewrote this, I've got the limit as x approaches 0 of negative 1 over 4 times x plus 4. I can now plug in 0 for x. That would be negative 1 over 4 times 0 plus 4. That would be negative 1 over 16. So again, let's recap that one. We rewrote this instead of numerator divided by denominator as numerator times essentially the reciprocal of denominator, 1 over denominator. We then get our common denominators and simplified. If you do this correctly, most of the problems that you'll see, things will naturally cancel out. And as things cancel out, you get to a point where you can plug in your limit value. Now, when we're doing this, we have to make sure that we're writing limit every single step of the way. It will get tedious, and we're making sure that we're going to keep track of our work. The more and more you get used to these, some of you will be able to jump from this step right here, down to this step right here, down to the answer. So just kind of keep that in mind as you're working through these. All right, so just as a recap, when we evaluate limits, first option is always to plug it in. If you're lucky, you get a number or you get 0. But as we discovered today, there will be plenty of times where you get 0 over 0, in which case you have some way, some shape, some form that something can cancel out. All right, that's it for this video. You know the drill. If you have any questions, do not hesitate to ask. As always, folks, good luck, have fun, be safe. Roll Tide.